Hi everyone. Today we are going to talk about an important topic of in telecommunications. The topic is FrameRelay. So this protocol played a key role in connecting local networks for over long distances, especially in the 19th and early the 2000s. This presentation is for understanding how the frame relay works, and it is still important for understanding how the networks have involved in the actuality. So, and I hope that the presentation that you like it.
So, what is a frame relay? A frame relay is a high-performance packet switching WAN, a wide area network, a protocol designed for efficient data transmissions between local area networks, like a LAN, over long distances. It was developed in the late 1980s and widely adopted in the next decade. Is usually used to connect geographically dispersed locations such as brand offices and data centers.
Frame switching. Frame relay uses a packet switching that allow data to be sent in the forms of frames. These frames can vary in size, typically between 1 and 80,250 bytes. That the file size is 1060 bytes. Connection oriented. This technology establishes virtual connection which can be permanent PVC or switch SVC. This means that data is sent over a predefined path in the network, improving efficiency and reducing latency. Statistical multiplexing. Frame relay allow multiple virtual connections to share a single physical lane, thus optimizing the use of bandwidth. This translates into lower costs and greater flexibility for users.
And now we're going to get in the most important part of the presentation, which will help us to understand finally what the frame relay is and how it works. So what I'm going to do is to explain a quick summary of the process flow of the frame relay and then its complete processing. So with the process flow, this is divided in four principal steps. So the first one is that the data that we have are going to be packaged into frames. Frames, we like to say, are like units of data, like we put a lot of data together. And then when we have the frames, these frames are going to be identified with a tool called the DLCY. And when this happens, we're going to send the frames throughout a virtual circuit. When we already have this, the frame relay network are going to transmit the frames to their destination without performing error correction. This is mostly for to analyze if the frames are really correct and these things. And finally, the service provider of the frame relay are going to manage the route of the connection and are going to apply changes based on the transmitted traffic. And now we're going to continue with the complete operation, which is basically the same steps that I already said, but with a little more deep. So the first step is the physical connection and the multiplexing. So in here, the frame relay allows several devices to connect to a single physical link, either through a router, a bridge, or a switch. In here, the physical link is shared by multiple virtual connections, or also called virtual circuits. And throughout the multiplexing, the multiple data frames we already have, that are the units of data, can be sent over the same physical link but assigned to different logical connections. Then the second step is the connection identification, the DLCY, the tool I already said. So in here, each logical or virtual connection within the network is identified by a data link connection identifier of 10 bits. So this tool is used to correctly address each data frame to its assigned virtual channel, we need the share link. So basically, this all allows the network routers and switchers to know to which virtual connection each frame belongs to. And now we have the third step, that are the encapsulation and data transmission process. So when the data is ready to be sent, it is packaged into units called frames that we already have talked. So these frames are variable in size and contain both the data to be transmitted and the necessary headers to ensure the proper delivery, including the DLC-Y. So the device or the router or switch, whatever you will be using, that originates the transmission package, the data into individual frames and sends them through the shared physical link. So each frame contains a DLC-Y, which identifies the virtual circuit to be used for that communication. Now, with the first step, I'm going to explain the types of connection that we can use to send the data or the frames of data. So we have the permanent virtual circuits that, as the name say, these are logical connections that are permanently configured and maintain an active connection even when no data is being sent. And we have the switched virtual circuits that, unlike the first one, these are temporary connections and are only established when data needs to be transferred or sent in the moment. So with already this set, we can pass to the 5 step, that is the routing and delivery determination. So in the case of the permanent virtual circuits, all throughout the customer perceive a continuous connection, the FrameRelay service provider manages the specific road that the frames will take within the network. So this routing can change depending on the traffic optimization of or with the network congestion. But from the user perspective, it always appears as a single direct line or road, as you want to say. And from the frames sent throughout the switch of virtual circuits, a specific role is established for the duration of the session. And once this transmission is complete, the circuit is going to be evaporated, we can say. And finally, I want to add two additional concepts that are really important from the frame related function. So first we have the error correction. So when the frame relay network does not have to transmit erroneous frames or when the data becomes corrupted during the transmission, it's up to the endpoints to handle the retransmission, basically. And the usage-based built-in in here, the frame relay service provider changes user based on the actual traffic transmitted throughout the virtual circuit. Basically, you're going to be your prioritization as a user are going to change depending on the data or the congestion of the data that are being sent to you. So with these all 6 steps, I'm sorry, you have the complete operation of the frame relay.
And what about the virtual circuits in which it operates? We have two: the permanent virtual circuits or PVCs that are pre-configured static paths established by the network provider between two endpoints that are always active and available and reduces setup time. And also we have the switched virtual circuits, SVCs, that are dynamically established when data needs to be sent and are turned down once the transmission is complete. Is more suitable for temporary connections and at some delay by the setup. Each of the virtual circuits could operate in different ways. One of them is data link connection identifier, in which each VC is identified by a unique DLCA, the data link connection identifier, a numerical identifier assigned to a connection between two frame relay endpoints. Other could be the logical connections over shared physical links, in which virtual circuits are logical, meaning that multiple VCs can share the same physical connection, like a list line or a T1 link.
Hello, my name is Ariana, and today I'll cover the advantage, disadvantage, and the performance. So, and at first, then we have the efficiency. FrameRelay is more efficient because it uses a fewer error checking step compared to other protocols like X25, and this reduces the overhead, which means the data can travel faster, especially on reliable networks. Um, Another big advantage is the cost effective. Frame relay lets multiple virtual connections color circuits, and these circuits share the same physical networks, and this reduces the need for expensive dedicated lines. Then we have the scalability. It is also highly scalable. Frame relay can adjust to different amounts of data traffic, making it ideal or a good option for the small and large networks. And then we have the support the bursty traffic. It works well with bursty traffic too, which is when large amounts of data are sent occasionally instead of constantly. And this type of traffic is common in business networks, and FrameRelay can manage this data burst efficiently. So now I am gonna talk about the disadvantage of the FrameRelay. And at first, they will have a no error correction. One on the downside is the FrameRelay doesn't have built-in error correction, unlike the older systems like X25. It leaves the task of fixing error to the devices and the ends of the network, which can be a problem if the network is unreliable. They will have performance degrade with congestion. Since FrameRelay is a shared network, the performance can drop when there is a lot of traffic. So, if too many users are sending the data at the same time, the network can slow down to do the congestion. And they will have a limited to the low speeds. Another disadvantage is the FrameRelay typically operates at lower speeds compared to the newer technologies like MPLS or broadband. So now I'm going to explain the frame relay performance. And at first they will have a low latency. So in terms of the performance, frame relay typically offers low latency because it avoids most of the processing overhead that comes with error correction. This makes it fast, especially when operating in environment with reliable transmission. They will have another. They will have a handle congestion. Frame relay includes a mechanism like fetch that significates forward explicit congestion notification and bench backward explicit congestion notification. So this mechanism bench and fetch helps to the manage network congestion. So these indicators alert the network devices to reduce the transmission rate if the congestion is detected, helping in maintaining performance during the peak times. And then we have the throughput. In reliable networks, the throughput of the frame relay can be high because there is less overhead. However, as I mentioned it before, in less reliable networks, the lack of the error correction can lead to performance issues if the data frames are dropped or corrupted.
And now I'm going to explain to you the three principal applications that we can use the frame relay in. So the first one are the enterprise networks. So the frame relay is commonly used in enterprise networks to connect branch offices and remote sites. So this protocol enables the efficient transmission of data and critical business applications. So in this way, we can enhance the communication and the productivity and also ensure that the most important data gets through more quickly and fastest. Then we have the service providers. So the service providers use FrameRelay to offer connectivity services to their clients, allowing them to establish reliable and cost-effective ones. Also, its flexibility facilitates integration with other networking technologies. So, in this way, we can enable service providers to offer a wider range of services. And lastly, we have the internet access. So, the phone relay is also used as an internet access option for business users. So, in this way, the phone relay can provide transmission speeds more suitable for the connectivity needs. This is particularly useful for companies requiring a more robust and low-cost internet access solution.